Hello, everyone. Thanks for joining us today. We've got a lot to cover this hour, so we're going to try to jump in as quickly as possible. We know many more team members and participants will be joining here shortly. Thank you for taking the time to join us for our last webinar of the year. Topic, of course, is wireless. Today we have with us our experts, Keith Skidmore and Jason Graham. They have a lot to share about wireless. And in fact, you may drive some questions. If you have questions, please use our chat feature to this event, and we'll try to address them at the close of the webinar. We also will be recording this event and putting it on our YouTube channel. Send a link to the recording to all of you as well, so that you have it as a reference. Again, thank you for taking the time to join Interface today for our Force Leaders event. And here are some of the topics that we'll be covering today. To start, we're going to go over a little bit of just about the history of wireless and how it's used in test and measurement, why it's growing in use and popularity, types of wireless sensors that are available from Interface. We're going to give you some examples about making the connection to instrumentation. Really important conversation. We'll talk about the complete wireless telemetry system and what components are available and how they all work together. Talk about some key challenges and considerations that are important with some engineering tips as well for whether you're applying this solution in the lab or the field. And then we'll finish up with some applications and use cases and FAQs. So to kick things off, again, Keith, Jason, it's all yours.
All right. Hi, everybody. Thanks for coming. Talking about history of wireless a little bit. It's actually rather interesting. Wireless was first shown to exist in 1888 by Heinrich Hertz. You may recognize that last name, where he demonstrates the existence of electromagnetic waves. 1895. Someone named Marconi transmits the first wireless message over a distance of almost 2.5 kilometers. In 1901, you got the first commercial radio broadcast. 1921, first commercial mobile phone service. I had no idea mobile phones were something back in the 20s, but here they are. 1940s, radar. 1960s, you have the transistor and integrated circuit. And then 73, we've got the first commercial cellular phone network. Again, that's a lot earlier than I might have expected. The 80s, we have development of digital cellular networks. In the 90s, pagers and wireless computer networks. Some of you may remember pagers. In the 2000s, we've got Wi-Fi and Bluetooth. In 2010s, you got 4G and 5G cellular networks. And then that brings us to today. So wireless in test and measurement. First known wireless load cell was invented by General Electric, and it was used in radio broadcasting to actually measure the weight of the antenna. And then I guess it was convenient being next to a wireless radio transmitter. They were able to transmit the data wirelessly. So that's the first example of test data actually being transmitted. So today we have a lot of different components that are wireless. You got IoT stuff, you've got sensing and measurement stuff. You know, your homes are full of wireless items. Specifically today we're talking about sensors, and here's a wide variety of things shown in this picture, showing sensors and also receivers, or things that are used to display or retransmit the data. On to Jason. Or that's still me. Yeah, changing requirements now in the future. So basically, you have a bunch of different components. Some people are actually taking data up to the cloud. Got environmental concerns and getting better at weatherproofing things and making them able to be used in harsh environments. More precise measurements. Again, as time goes on, people want not just convenience, but more accuracy and more precision in their measurements. Automation, sometimes it's quite easier to use wireless when you're adding a sensor into something that already exists, trying to automate it. Again, for continuous monitoring your processes and things, maybe out in the field, wireless is a good way to go. Adding safety alarm systems, as customers find, say issues, maybe safety related, you add sensing into the system to kind of prevent that instance from happening again. So we're seeing a lot of that where something may happen and then add sensors to prevent it from happening again. Or preemptively, if you smart, may add the sensors ahead of time to make sure it never happens in the first place. Something like a crash or something breaking or being dropped, for example. Next slide. Now on to Jason.
Why wireless is growing in use. So one of the first reasons is it's much easier for installation and maintenance in itself. So there's not a whole lot when it comes to wires. We're dealing with battery operations with regards to the power supply. So you're kind of decoupling a lot of that. The duration can be changed when you start looking at managing the power with the batteries as well as the sample rate. So you can extend that. We do have some parts of toolkits which allow you to monitor different parts of that. Very maintenance free. Most configurations can be done remotely. You've got a base station. The device can be out somewhere, and all you have to know is the ID of it, and you can remotely configure it with some additional devices. Next. One of the second reasons is we can reduce the wiring costs, and it's much easier to integrate. So no wiring, we already spoke about it, reduce the costs, and it increases the simplicity of the installation. So when you're looking at maybe a load pin and you're integrating it in a crane, you don't have a wire that you have to run down. You just have a load pin or something, or a shackle. The signal can be transmitted over a large distance, and that's a benefit when you're dealing with cabling and wiring and whatnot. Integration into PLC and automation, as Keith pointed out, when you start adding a lot of different sensors, wireless is a very simple way to look at adding multiple sensors with a quick integration. Next. Increased flexibility and scalability. So when you start thinking about integration and you start looking at multiple sensors, growing a system is very simple. Transmitting the data is also easy because you've got load cells or sensors in different locations, and we're not dealing with the wires. And you can connect a variety of different load cells or wires up. Along that lines, we can take the wireless can convert the sensor signal into a usable signal. So it'll take the analog one and then digitize it, and then we can it'll be read as a voltage, milliamp, RS-485. There's a variety of different others. Next. The reduced risk of electrical interference and noise. So grounding issues were pretty much completely or reduced and mitigated. Excuse me. The electrical noise is almost gone. Since we're not dealing with the cable, you're not dealing with EMI. A lot of the things that would be coupled into the cable or where you'd have to have sense wires long runs, this makes it a lot easier when we start dealing with noise. You may have some electrical noise or interference in the 2.4 gig range, but it's not through the wiring. Next. So improved safety, no cables, another upside of wireless. In a lot of, say, lab applications or something where you start dealing with cables, you don't want a user tripping over something. Now, if you get in an industrial area, there may be more cables, a lifting area, something like that. This is definitely an area where you do not want to have somebody tripping. By doing this, it makes it a lot simpler. When you start looking at damaged connectors or things like that, think of a 400, 500 pound sensor, something that may be moved or taken in, taken out, or could be damaged. By going wireless, perhaps the calibration can be done in rig, can be done, a little bit separately. Pins don't get damaged, they don't get disconnected. So you see a little bit more robustness long-term and less maintenance as a result. It also provides the ability to untether sensors from the instrumentation. So think about integrating a sensor in a difficult spot where you need to get readings, but cabling is a very difficult task. Maybe something rotates or it's a chore. So it's another upside is untethering sensors. Next. Keith.
Types of wireless sensors. All right. So basically, we can provide wireless data from any sensors that we manufacture or sell. This is our low profile load cell with an integrated wireless module attached to the side. And this could be a 1200 series as shown here, could be 1100 series, could be basically any of our low profile type load cells with this. It could be single or even dual bridge transmitting data. These would be calibrated with the load applied, and then the basically the signal, the wireless signal as the data that gets calibrated on certificates. So something like this could be shipped as a wireless load cell. It's broadcasting in pounds, and then anything you receive it with would be receiving that pound data. So a calibrated system integrated with the sensor. Next slide. So this is an example of a mini type load cell attached to an external wireless module. This is a small one that takes a couple AAA batteries and broadcasts wirelessly. This is a small torque sensor. Reaction torque sensors are sometimes paired with wireless sensors. I'm sorry, wireless transmitters, so that say if it rotates or reciprocates, you could actually not have the wiring get wrapped up. You can see it's transmitting to a handheld or to a dongle that goes to a PC that allows logging and graphing of the data. Next slide, we've got something called our SSM, which would be basically another type of mini load cell, connect to a little bit larger transmitter. This transmitter has two AA batteries in it, so you get a little more battery life. It's a little larger, has an LED on it so you can tell when it's active or not. So just a different type of acquisition module. It's a load pin with an integrated wireless module. Again, where the head of the pin is, we can integrate a wireless module. On very large pins, the head is quite large, so a big or a module on the end is no problem. On a very small pin, you'd have to wire it up to an external module, which we do all the time as well. But load pins very nicely want to be wireless. A lot of times they may go in a sheave in a crane or a pulley or some kind of an overhead system, or somewhere where there's a pin that gets replaced with a load measuring pin. Now you can have measurement data, but it may be inconvenient to run all the wires, so the wireless becomes quite handy. Battery life, that's a question. I'll address it now because I did mention we have different modules. So basically they have a lot of power saving features and whatnot, so they can go to sleep. But continuous broadcasting, say at the maximum sample rate, might be a week. That'd be continuously running. If you're running it, say 8 hours a day, it might be a month. If it's say waking up and sleeping sort of as it's used, you might get several months to a year. So it really depends on the duty cycle. And there are ways to manage that via the other components. You can basically tell these things to wake up when you want to take readings, and then they go back to sleep when you're not. So anyway, from weeks to months to years, depending on the module and on the sort of the power management features that are being used. This is a tension link, which again, very useful for lifting. It's easy to integrate something like this. If you use a regular load cell, you just have to figure out how to match the threads and, maybe make or break connections or modify things, where a lot of times a system that's lifting may have shackles. You can put a tension link right in line with a shackle. Tension links are more accurate than load shackles. So if again, a tension link can be fit, it's usually a good answer for lifting applications. And again, wireless, anything that's moving around, lifting, moving cargo or moving equipment, typically wireless makes a lot of sense. Next slide. So this is a load shackle. Again, if you can't use a tension link, a load shackle makes a lot of sense. A lot of shackles in use. You can very easily swap out an existing shackle for a load measuring shackle. In some cases, we can just add a load pin to an existing shackle, make it wireless. But again, for moving, lifting, tension testing, all kinds of things that may require the use of a shackle, it's easy to integrate a measurement. And that measurement is likely wireless if it's, say, a moving item, say on the end of a chain or something. So this is an interesting application showing a product called our BX6, which is kind of a different ecosystem of products, but it is Bluetooth wireless, has an SD card, has 6 channels, and does bridge completion. So somebody might wire their own strain gauges up to this. This shows it mounted on an axle that might be spinning. This is some of the simplification of how it might be mounted, but we didn't want it to look ugly. But you might wrap it with tape or a strap or something to keep it on. Again, it's more of a do-it-yourself approach, but this is able to transmit up to 600 samples per second. And it does, say bridge completion and things. So it's useful for use with strain gauge wiring. Again, logs to an SD card, but also transfers the data simultaneously via Bluetooth. Next slide. So we're talking about integrating sensors. Any of our sensors can be integrated with wireless. Also, though, there are a number of different types of sensors that you might have that you already have that you want to integrate, or you may want to build a system. So any kind of pressure sensor, whether it have millivolts per volt or milliamp or voltage output. We got position sensors. That could be an LVDT. It could be a linear pot. It could be a string pot. It could be a laser, even with a voltage output. Could be an encoder. Again, proximity sensors, that'd be kind of like a switch on or off. We could transmit that via voltage transmitter. A level sensor, again, that might have milliamps or might have some kind of an analog output, vibration. We don't have enough data frequency to actually do, say, frequency from accelerometers, but there are lots of vibration monitoring applications where, say, there's a voltage output that varies with frequency. Say for condition monitoring on pumps or motors and equipments, definitely we can integrate that wirelessly. Basically, also a bunch of different kinds of temperature measurements could be wireless. So basically any kind of sensor you have, we could certainly connect it wirelessly. Speaking of connecting to instrumentation, on to Jason.
Connecting to instrumentation. So we have there's a variety of different wireless instrumentation available. Anything from displays, which is your large displays, portable and handheld devices, some of which would be the blue devices on this page, data logging, acquisition systems, a variety of different software, enclosures, which would allow for either display of devices, key locks, accessory devices. There's a variety of different things that can be used for wireless instrumentation. Next. Wireless displays. Interface provides, we have a variety of different wireless displays available. This slide shows 4 different displays, 2 of which are the 2 large displays. And then there are handheld, and then there is also another display that would be mounted in a device. If you look at the features and benefits for these displays, it doesn't apply to everyone. The large displays you may see in a large lifting application, in a place where you want to see a value for whatever measurement, but you need users to see that. The handheld, just like any of the other handhelds, convenient, portable, and then the other one has relay outputs for alarms. So a few different options with regards to some of our wireless displays. Next. Now, if we look at wireless portables, we have 3 different portables that are available. Each one kind of has a different, price point and options that are available. And some have a lot of features and benefits relative to other ones, depending on what you use it for. So we have an unlimited, a multiple, and a single. A single transmitter would be kind of like a wireless portable that pairs with another single transmitter. Very simple, very easy. A multiple would pair with multiple other transmitters, up to 12. You could cycle through the sequence of those transmitters, and that sequence would be the same. Unlimited is slightly different. This would be more of a unlimited number of transmitters, but it does utilize the ability to identify which transmitter has the highest power signal. So if you were walking around a floor and there was a variety of different sensors and you wanted to get readings off of the closest sensor, an unlimited one would be a sensor that would allow you to get that highest reading from the one with the closest location. Next. Interface wireless data logging. So we looked at that BX6 OEM that was on the axle earlier. it does have the ability to do some logging. There's an SD card that mounts to it. It has a lot of different forms and features. That same OEM version can be expanded. We can get, instead of maybe solder pads, you've got some cable glands, you've got an enclosure, you've got maybe points for your wiring that's a little bit different. They both provide about the same function, and they do connect to software for the data logging, but both are options within that BX6 Bluetooth wireless feature. Next. Wireless software log 100. So wireless software log 100, this is kind of, this is a software that would allow the, say, up to 100 different sensors to provide an input. That sensor input could be displayed however a user wanted to. If a user had a different format, it's a common use in, say, a maintenance situation where you wanted to raise something, lift something, and get a uniform force or a uniform mass, or lift it to a uniform level. This would give you that ability to do that. You could set kind of like red, green, yellow, are you in, within, or not? And then that could be displayed on a smart tablet or phone. Again, it would require a little bit work with some of the mapping, but it does provide a very easy, handy, quick interface for you to look at. Next. So wireless software, BlueDAC. So BlueDAC software is a software, and it works with a variety of different I would say, devices. When we look at it with regards to wireless, we're kind of associating it specifically with that BX6 Bluetooth and then display there, and then the kind of what do we do with the data. There is another way that we can do it. We can get any of the wireless signals into a wired or analog format, which feeds it into devices, which could then feed into this. So this is one version. It's associated with a couple different products, but it has the ability to be used across more products than just one. Next. So there's a wireless software toolkit. So again, with some of these devices, maybe a wireless transmitter would have this software associated with it, where maybe that log 100 software would be associated with something else, maybe the reading side. This is more maybe the service configuration, and it could be tied into maybe some logging features. But when you look at it, the configuration part, it allows you to do pairing. It allows you to look at battery life. You can do estimated battery life based on sample rates. So there's a lot of features this has when it looks at kind of whatever that device is, or the wireless device. Testing, the picture itself does show you spectrum analyzer showing frequencies. You can look for noise and whatnot in your local environment as well. Next. So now when we want to make this connection, so say you want to go to a DAC, data acquisition system. So on the right, we have a low profile wireless load cell. It's essentially just transmitting the wireless signal into a digital format that gets transmitted over. The WTS BS5, which is the black module in the middle, that would take the wireless signal, convert it to an analog output, and that analog output gets fed into that BX6, the gray box. The BX6 is basically a data acquisition module. That could be fed into any other device beyond BX8. In this case, we use that as an example. Use cases, you may see this in labs, robots, and then if a BX8 wasn't used, it could be integration into an existing site where you may have an existing DAC, but you want to integrate new sensors. Next. So now if you want to make the connection, so use case for the so say you have a PLC. Now we're going kind of into a digital converter, but we're not going into a PLC directly. So we're taking, in this case, a tension link. Tension link provides that wireless signal over. Wireless signal goes to, and in this case, it's a gateway. So a slightly different device. We're not converting it to an analog signal out like the BS5 did. It looks like the same box, but different output, but it does provide an RS-485 Modbus output. So it's a digital output into that other device. This would be something upon customer request. They would know kind of what their environment is. So this is kind of, if you're not doing analog, you're doing digital, but you're not doing, say, a syntax into your PLC. Next. So now when we talk about connecting to your network, we're kind of looking at how do you integrate from the actual sensor all the way through to the PLC to the network side. So in this, we've got a wireless load shackle transmitting the data wirelessly. That data goes across, and in this case, it goes to a gateway, just like the prior picture. The gateway then takes the digitized data, converts it to an analog signal, or converts it to a signal. It's Modbus or 485. That goes over to an AnyBus module, and then we have a variety of different options that would allow that conversion to a Profinet, Ethernet IP, Ethernet, TCP IP. So there's a few different options with regards to that, and it's really fundamentally what is the environment that say you're working with, and how do we get to that? It's just a language conversion essentially. Next.
This is kind of just an overview of the WTS system wireless components. So basically we've got transmitters and receivers and software, and then other things. So moving on to the next slide, talking about the transmitters. So the transmitters can be integrated directly onto the sensor. You say into, but usually they're like mounted to the side, as you can see there on the left. And then we also have various acquisition modules that can be connected, say, wired to the sensor. So a lot of times, say a sensor exists already in the field, you want to make it wireless, we just offer the acquisition module. The sensor is wired to that, and then that transmits the data digitally. The thing on the right is kind of cool. It's a wind speed monitor. Say, why do I care about that if I'm doing testing in a lab? Well, you probably don't. But for lifting and things, outdoors, a lot of times wind is a consideration, and it's very safety related. So, instead of seeing these large loads on, what you're lifting or whatever, it's maybe a little too late. But if you notice the wind speed coming up, maybe shut down the test, or, shut down the equipment and run for cover. So, wireless receivers. Again, once the data is, say, digitized and transmitted, it's in the air, and you can listen to it with any number of different devices simultaneously. Just like if you had to, listen to the radio, you could have 3 people listening to the same radio station, or 100 or 1,000 people listening. So you can basically listen with any number of different devices. Those things can be interfaces, which basically take the digital data and then just say convert it into another digital format. So we got Modbus 45, which Jason talked about earlier. We've got USB. That's super common. So just taking it into the PC via USB port. ASCII serial output module, which is very specifically sending ASCII serial data. And of course, you've got displays. You have big LED display. You got handheld display. You have panel meters, and then analog output modules, which convert to, say, a 4 to 20 milliamp or plus or minus 10 volts. And interesting thing is, right, you could have a gateway attached going to a PLC. You could also have a handheld. You'd have a big display up on the wall, and then you could also have, say, an analog output going to a data logger, and then you might have a relay module that trips some kind of alarm at certain, conditions. So all of those things could be operating, say, simultaneously on a number of different sensors, or just a single sensor. Next, we've got, again, software and cloud, depending on the configuration, what kind of software may be available, also what your use case is. We have various things we can offer. And then, again, it's being more common where people want to take the data up to a cloud database and then be able to, say, distribute it to multiple locations, or have it be, say, available in the office, whereas the data is being captured over in a factory or something. So lots of options. In accessories, we've got different kinds of battery packs. You have rechargeable batteries, battery chargers, different antenna options. Imagine this is line of sight. It's Wi-Fi though, so just like your router at home or whatever, it bounces through walls and everything, but you start to limit the range depending on how much obstacles you have in the way. So say you've got a sensor inside of a metal enclosure, it might be that the data doesn't like to get out. So we might mount, say, a repeater inside with an antenna mounted on the outside through a feed through or something. So lots of things we can do to kind of get the signal where it needs to be. The antennas can also be signal boosters too, if that's necessary. Moving on. So custom, we do a lot of custom stuff. Basically define what it is that customer wants to do and then develop a solution to address it. And so it could be a lifting application where say, oh, something got damaged. Now they want to prevent that from happening next time. So put some modules in the box that have relays, maybe a light or an alarm that goes off, or some kind of an air condition that's tripped or acted upon. We can do enclosures, different kind of batteries, battery chargers, whatnot, AC power or DC power. Just really need to define what the application is, and we can provide a solution. Bluetooth, we talked about Bluetooth a little bit. That BX6 is only Bluetooth. All the wireless modules are 2.4 gigahertz. We can also do Bluetooth in some cases. The difference being that the WTS, again, being 2.4 gigahertz, so I have longer range, also has a sort of a wide range of other devices that are compatible with it. Bluetooth kind of limits you to transmitting to either a PC with like a Bluetooth dongle, or a lot of PCs have Bluetooth built into them now, or to an app on a cell phone or in a tablet. So you can imagine like in a test lab, you probably don't want all the data into somebody's phone. You want it into a data acquisition system. So this might not be useful. Now, if you're, say, doing some kind of device where you just want to have somebody walk over with the phone and check the level of a tank or something. Say you had barbecue grills or something, guy wanted to see how much gas is in the tank. Bluetooth would be perfect for that. So it has its place. Doesn't have quite as much range. It does have a lot longer battery life because of that. It's not transmitting with such power. So some OEM solutions require Bluetooth, for example. So basically just keep in mind that Bluetooth is available, but it's not necessarily ideal for industrial type applications.
Technical challenges and considerations. So when we start looking at technical challenges, there's a variety that we end up running into. Anything from interference, distance, data frequency, sample rate, and time stamping. So from interference, what's out there in the 2.4 gigahertz range? Is there something in the environment that could be affecting it? Something you need to consider. What kind of distance are we going to look at? Is it something that's relatively close? We can get through walls. Will we need a repeater? Are we looking at something where repeaters aren't sufficient, or wireless is impossible? Data frequency, what's the distance? Sample rate, is it sufficient? Is it fast enough for whatever you're going to be doing? Sometimes wireless isn't fast enough and we need to go wired. Time stamping and synchronization, is that a key thing for you? Next. So when you start looking at the key considerations from channels and frequency, wireless, it's 2.4 gigahertz range, so 2.4 to 2.4835. Most of the wireless modules, it's about a 10 milliwatt typical transmit power, about 15 channels. When you look at these spread across the channels, the WTS toolkit does allow you to kind of do some, I'd say, when you start looking at how much saturation is at certain channels within certain frequency ranges, so that's kind of handy. Next. Environmental and locations. So there's a variety of different locations that wireless can go into. Anything from, say, cranes, the end of a crane, so something, an anemometer, it's reading wind speed. So you're going to have to start thinking about waterproof, anything along those lines. If it's going into a lab, maybe it's just dust, no liquid. So that's an IP50 rating instead of an IP67. So fuel, oil, anything that is like safety or along those lines, ATEX, are those considerations that need to be looked at. So we've done some custom stuff around the ATEX before. So it's something that, if it is a consideration, certainly needs to be raised. Next. So the other thing would be wireless versus cable. Just making sure you're making the right selection based on the needs, accuracy, types of errors and servicing. How often will the batteries need serviced, or do they need serviced? Is line of sight going to be an issue? Is it not an issue? Data rate. Will the data be transferred? Will you be getting enough data? Synchronization. Wireless doesn't synchronize data. So now, is there something that we have to look at where that's a consideration? What type of sensors can be connected wirelessly? And then maybe the sensor output. If you're looking at an input into a transmitter module, making sure that you pair the right one. The other one would be the distance that sensor is going. Say you have a sensor and you need to have that sensor go over a long distance. Wired may not be practical because of either EMI or something. So there's a few different things there. Next. So from an engineering insight, say there's a spec watch list. So you'll look at what's our input range, sample rate. So now we're looking at, each of the specifications for the load cells, for how they're paired with that wireless device. So in some cases, we may have, say like a temperature range of the wireless device. You look at, is that acceptable? Can it be used outdoors? Temperature errors, what are the potential temperature errors based on the environment that you may have that device in? Environmental ratings, inside, outside, submerged, not submerged, ATEX or safety, some secure ratings. Battery life and power supplies. How long will that device be in use? How many times will it be sampled per day? This is that point that Keith made, kind of when you start looking at battery life and battery power and how that's managed. You can manage that to some extent with the toolkit by changing values, sample times, and things. So compatible output and inputs of every component. It's just making sure that every component works with the next component down the line. We just want to make sure that's something that our application engineers can certainly ensure that that system or that solution is something that works out. Next. So engineering insights from a calibration perspective. So we have system setup and calibration. So a lot of times system setup, that would be something where maybe that load cell is paired with the wireless transmitter, and that could be set up. So it's kind of a plug and play. It's a solution that we have the calibration done. They're paired, they're ready to go. It's just kind of provided there. That would be something that could be provided as a paired solution. Linearization, so say some load shackles, maybe we need to improve or look at improving linearization or something along those lines. There's options there where we can look at doing that. Interchangeability of components. Frequency of calibration on a sensor. Interface suggests about a 1 year 1 year rate. Now that calibration of the sensor, that could occur in situ. So is that something that the calibration needs to be sent, the load pin or something needs to be pulled out of, say, like a crane or something, sent back to us? Or maybe that the calibration is an in-crane calibration where they do a live load calibration, lift a known weight, and do a recal, and that's a calibration that they can certify. What types of certifications are required as part of the calibration? Calibration protection and lockdown. So say a device is provided and we want to make sure that users can't modify that calibration, change it, or make any scaling or unit adjustments. Those are options. In lab or in field requirements, and then handling devices protocol. Next. So troubleshooting. So there's a few considerations along the lines of troubleshooting. A lot of this is kind of basic wireless, but it does come into play when you start looking at sensors and adding sensors. Line of sight, when you're dealing with wireless, line of sight, it does penetrate through walls and different things. There may be a point at which your signal strength may be degraded, or you may have packet loss. And that's where you might look at adding a repeater or doing something to beef up that signal. Installation tips, it's a matter of just, installing devices in good places. There are folks that have been doing wireless installation for a long time. Environmental, making sure that from a load pin perspective, that you've got the right environment, or any device, you've got the right environmental ratings, that you're putting devices in places where they're supposed to be, cable glands, connectors, the right sealing. When it comes to connectivity, are the wires connected? Load pin, load cell, is this an external transmitter? Is it a internal transmitter? Battery, there's a few different things that we can look at as well with the WTS toolkit that allows us to do troubleshooting. So part of that would be, are you looking at your signal strength? Are you looking at your power? Are we looking at the duration of the power? Is it paired? What's the signal coming out of it? And in some cases, from a cable length consideration, that when it's wireless, it shouldn't be a big deal. But if you have say you have a display, or you have something else that does have cables, is there something along the lines with those that does need to be investigated? Next.
Tips for using wireless in the lab or in the field. So basically for the lab, what devices do you intend to use? Of course, if you buy load cells from us, we can make it wireless. What else do you have that you may want to connect? In software requirements, sometimes people just want to display. Otherwise, they may want to log into a file that's compatible with Excel, or maybe you want to be able to draw graphs on the screen. So just need to understand what the requirements are. Again, reporting needs, you want to be able to print reports, or somebody just want to eyeball something and say good or bad, right? If they need to report, what format, what do we need to do to make sure the data is compatible with the formatting required for the reporting. Again, how to connect to a data acquisition system. May already have an existing data acquisition system, but you want to add, say, some sensors, or you want to add wireless capability to existing sensors. How do we connect to that data acquisition system? That's very specific to, the exact system. May have a Modbus 45 input, probably not. May have some Ethernet, EtherCAT, some kind of connection. If so, need to know that. Very commonly, they'll have analog inputs, and that's pretty easy. Just use a analog converter from the wireless system to analog that connects to the DAC. But again, we're talking about ahead of time, instead of getting the items in and then finding that, didn't get everything necessary to make the connections. Again, might consider adding wireless capability to existing sensors. And if so, again, what are those sensors? Where are they? What's the data frequency? Again, like something like an accelerometer, probably not a good candidate for adding wireless to. If it's a position sensor, yeah, quite possibly, or a pressure sensor. So just things to consider. And we've got tips for using these in the field. In the field, what are your power sources if it's out and about? Sometimes people use solar power if they don't want to ever have to change the batteries. Sometimes you can hardwire the power to the acquisition modules. If you have local power available, you don't want to run long cables for the data transmission. Or just, you could use a big battery too, if you have room, or one of these little battery modules where you might have to go in and change the batteries frequently. So just things to consider. Again, what instruments need to connect and where are they? Might do a site survey. If you've got say a control room or something, you want to get data into that room, where are all the devices located that would be transmitting to it. Might need repeaters or external antennas or things. So also environmental exposures. Again, the field, these might be out in the rain, the snow, might even be submerged or dunked in the water. That may be okay, but we definitely need to know that. Again, what type of water or fluid? Is it oil? Is it rain? Is it ocean? Lake water? All those things are important. Again, calibration, standards, and frequency. Sometimes in the field, it doesn't make sense to say pull sensors and send them back for recalibration. A lot of times, field calibration is not only possible, but maybe the most desirable method, especially something like a pin that's in a crane or something. It's really best calibrated in that situation versus, sending the pin to the lab. You really want to calibrate the whole assembly, including the sheave and the interface mechanically to the pin. So again, picking up a weight or a known weight, or having a company come out with known weights and doing an on-site calibration may make the most sense. Again, you need to change battery sources, hardwire. I mentioned that earlier, but again, sometimes hardwiring makes sense. Again, some of these integrated modules don't have as long a battery life as like the big external module that has D-cell batteries, for example. Or again, you can even use a car battery if you needed long battery life and want to change it out less frequently. All right. Now we're going to talk about applications. I think Jason goes first on this one, though. So.
Yeah, wireless applications. So the first one would be like a crane capacity verification. Pretty much the challenge is we've got a customer and they want to know the capacity that they're lifting with that crane. In this situation, we're using a wireless tension link, and then it's transmitting to a handheld display, and the data is also being captured to a laptop. Very convenient, very handy. The wireless aspect of it makes this a very simple solution for the customer to just identify what that crane capacity is remotely. Next.
So this is a kind of cool little setup. Some load cells, these would be low profiles with wireless modules, a portable case. The customer can bring this somewhere, install the load cells. Imagine running the wires might be a pain in the neck. So this eliminates the wires. It's battery powered. They just take some data. Could have a PC attached to this and also have a display for visual representation of what's going on. And then when you're done, pack it up in the case and put it away. So wireless is quite nice for something like that. Especially, if it's going to be temporary instead of running cables and then having to take them back down. They talk about trip hazards and things. With good cable routing, you don't really have trip hazards, but a temporary installation, it can be a real pain in the neck to do a nice cable installation, whereas wireless, you don't have to worry about that at all.
So this is an unusual one, inflatable space habitat. So imagine testing a space habitat, and we need to understand the burst of the material that is being pressurized. So there's some clevises, some load pins that are wirelessly sent to a laptop. You pressurize the habitat, and at some point it will fail. Well, we'll have that documented and identified. So it's more of a development R&D thing, but a very interesting use of a wireless load pin.
Here's one, gantry crane weighing. There's a lot of cranes in the world. Some of them have weighing built into them. Many of them do not. So adding in, say, weighing capability is a very common application. That's nicely done with load pins if there are already pinned connections, or things like shackles, or the hooks and things may already have pins. So this application, the wireless pin was put in place. Is transmitting to a handheld display so they can say monitor load. You can also have it transmitting to a wireless dongle attached to the laptop, so maybe continuously monitoring loggings. Every time this crane's used, they have a record, and maybe something goes wrong, you can go back and look and see what happened. Was it actually, say, loaded inappropriately? Or if something safety related happened, you have evidence that you weren't using the crane out of its say intended load rating. Next.
So bridge lifting and positioning. So very similar to a lot of these other ones where we're doing lifting applications. We ultimately need to identify what that weight is at the end. In this case, we've got two different cranes lifting as they're building this bridge. Load pins on each side, transmitting to a handheld display, a laptop with a BS4 base station. Very similar to a lot of the other lifting applications, whether it's pins, shackles, very, very easy and great places to integrate.
This is a cool application. Somebody with a robot, this is a university doing some study where they have a gripper that they made and they're gripping and moving an item. They wanted to measure the grip force, basically. They used or integrated very small shirt button style load cells right into the gripper, 2 of them, so they could measure like the pinch force. Because the robot was moving around, they didn't necessarily want wires hanging off it, so they used a wireless transmitter that was mounted up back on the robot arm a little bit and then wirelessly transmit the data over to a laptop to monitor force as this robot went through its motion.
All right, and a patient lift. So say you would need to measure the weight of that patient. 1200 LP load cell with a wireless transmitter integrated in it. Very simple. You could hang a patient, transmit that over, and that data could be logged with a different log software. So basically, you could use it to see what the lift could hold, and then you could also just measure, the actual patient weight if you're thinking, in this case, disabled patients, but variety of different applications. Next.
Frequently asked questions. So I'll start with this one. What impacts the range of WTS? There are certain modules that have, say, bigger antennas or more powerful transmission. So that's one thing. Also, line of sight, as Jason's mentioned a bunch of times, like say it's in a metal oven or something, right? The sensor signal may not get out. Or even if it's, say, in a building and you're trying to monitor in another building, does it make it through the walls? Just like Wi-Fi, it will. You can get your Wi-Fi signal in your backyard if your router's in your office, say, on the other side of the house. Not quite as good a signal, though. So the toolkit does have things you can look at, say, the number of packets per second. And what happens is you start to lose signal, you start to lose packets. So it might be sending, say, 3 or 200 packets per second or whatever you have it set for. Well, the farther you get away, you're going to start dropping packets, basically. So now it's instead of 200 per second, you're getting 180 per second, right? So that's how you kind of see what the impact is. But again, things in the environment basically do impact the range. I like this one too. Let me talk about this one. This comes up a lot. How reliable are the data results? Talking about packets, right? So when the packets gets lost, its data gets lost. You don't get wrong data, you just lose the data, right? And then also people wonder, like, well, what happens when you've got, say, battery issues or the battery voltage goes down? It takes a lot more power to transmit than it does to acquire. And so the acquisition always works while it's still able to transmit. And so you never get bad values. You just stop getting values. So as they say, the power falls below a certain threshold, you don't start getting errors or anything. You just stop getting data, right? But there's never a condition where low power creates, say, errors or bad readings. You just don't get the readings.
What software is provided with the WTS devices? For the most part, it's WTS Toolkit, and that would be software that would allow you to pair, and mainly with a base station, but that would allow you to pair, configure, set up a lot of your WTS devices. In some cases, the WTS devices would be set up or configured from the factory, and then a lot of that can be worked out with the application engineer that's setting it up. But WTS Toolkit is the main one. There are a couple other softwares that are available, not necessarily directly for WTS. How many devices can operate on one radio channel?
Yeah, that's a good one. The WTS does a maximum of 200 readings per second on a single channel. So if you had 200 devices transmitting once per second, that would be possible. So the limitation is really how many readings can be processed per second. But log 100 is called log 100 because it'll take up to 100 readings. So that's another answer. at least 100.
Can computer software gather data from many devices? Yes, log 100. What limits the radio frequency range of the devices? Well, the RF frequency itself is going to dictate the range to some extent. The higher you go in frequency, the shorter your range. Also, if there's anything that could impede or block your RF signal. You think of anything else, Keith?
Yeah, so interference on the
Yeah.
radio frequency too. So it could be at a different channel, slightly different frequency, maybe better. And the toolkit does have spectrum analyzers. You look at the different channels. So say you're sitting next to a powerful router, you can look and see, oh, that's on channel 15. Well, don't use channel 15. You might want your WTS devices on channel 2, for example.
What frequency does the system operate on? 2.4 gigahertz. Can wireless range extenders be used within the WTS network? WTS range extenders provided within the WTS solution, yes. And that's because of some of the specifics with regards to the pairing and how the devices interoperate. Is the system point-to-point? And that is a yes due to the pairing. What are the sampling rates of the transmitter modules?
Yeah, let's back up a little bit. The point-to-point thing, some of the devices are definitely point-to-point.
Yeah.
I'm not sure that, or one-to-one, we could call it. We're like one sensor to one analog output module.
Yeah.
But on the other hand, you could have 7 sensors to one PC software interface, the USB interface, for example. So it depends. They're not always one-to-one, but some of the items are definitely, like a display, basically, maybe paired only to one sensor. The handheld is displayed one at a time, but you can toggle through them. So it's one-to-one, but you can switch which one it is.
Yeah.
And sampling rates, typically it's up to 200 per second on the WTS, and that's limited. Again, that's also the rate limit of the channel. So if you have 2 sensors on the same channel, you can't each be set for 200 per second. They'd have to be set for 100 per second. We do have some faster options. There's a high-speed transmitter in the WTS lineup that transmits at 2,000 per second, but that basically consumes the entire channel, and so you can only have one of those on a channel at a time. And then some of the other stuff, like the BX6, uses somewhat different technology, and we can do up to, say, a couple thousand samples per second on a single channel with that device.
A lot of good information. And of course, you got a couple of questions during the event that I want to share with you, and you could provide answers for. First, we had a question about why do you have so many different software versions instead of just one platform?
Good question. It would be nice if it was all one thing. A lot of the hardware is developed through different partnerships, different times, same companies, even interface. We, have different projects for different hardware. It's just not always all compatible. So it would be nice if it was, but certain, technology changes, so things aren't always intercompatible.
Is it also functionality driven on some of those toolkit versus, as you say, the log 100?
Yeah.
All right, we had another question about is it LoRaWAN? Or I'm sure I pronounced that correctly. Is it possible?
Don't know what that is. You familiar with that term, Jason?
Not the acronym off the top of my head.
Yeah, I could say there's another question that may be related, and it says, can you connect directly to your own Wi-Fi network? And this is 2.4 gigahertz, but it's a proprietary format. And so the data, like say, even if you could connect it to your router, that would be the end of it. It wouldn't be able to go anywhere. It's not compatible really to transmit the data that way. So basically the Wi-Fi or 2.4 gigahertz is just between WTS devices. It happens to be that frequency, but it doesn't mean it can actually connect, say, to a router. There may be other devices that would allow that, but it's not directly compatible.
Yeah, it's not LoRaWAN.
Okay, that sounds good. What about the what would be the most efficient way to get the load cell data into LabVIEW? And do you offer a VI that interfaces with a receiver box of some kind?
Good question. One way is if you already had NI hardware, take a voltage input and you have your LabVIEW talking to the NI hardware. We also have some devices that are very nicely compatible, including the BX6. The BlueDeck software is actually written in LabVIEW, so any of the hardware that's compatible with BlueDeck is also quite compatible with LabVIEW, and that would be like the BX8, the BX6. We have a BSC4D, and then the WTS modules. There's the USB module. Those are Windows DLLs. They can be imported into LabVIEW, and so you can talk to all the WTS stuff basically via LabVIEW using imported DLLs. No VI is available though for the WTS, so it depends which hardware and what you need to do, but all of it is at least somewhat compatible.
We're also getting a question about, during the specification section, talking about values, the impact resistance, especially around load pins and shackles.
Good question. A lot of the shackles and load pins and things used in lifting do have kind of special certifications, the material, including like Sharpie hardness testing or Sharpie rupture testing and things, impact testing. So that is typically a function of the material used to make the item, but specifically not actually familiar with IK values, so I can't speak to that specifically.
Yeah, that's something that we could definitely help try to answer for you based on the type of device that you're looking at, as each one of those, as an example, a load pin or custom. Another good question, is a base station always required, or can I simply configure the transmitter to connect with my Wi-Fi network?
Base station.
Yeah, so that's kind of talked about that. That's not really until you convert.
Yeah.
All right. Good question. Some cranes on a truck have remote handheld. They could interfere seriously. How do you cope with that issue?
What frequency is the remote handheld? What interference? I guess
that's where you start to drive into the use case, as well as if there's a troubleshooting issue with an existing environment, or whether or not you need to look at that specifically by design. Is that right?
Yeah. Yes, and say if there is interference, right, there's really not a lot you can do except change the channel, right? But if it's this broadband 2.4 gigahertz interference, it may be insurmountable. So
yeah, I mean, you could force one of the channels. You can use the spectrum analyzer to see which is the best one and see if that mitigates it to some extent. But if the noise floor is high enough that that's not going to do it.
The one thing, interference basically creates packet loss, which creates lost data. So say worst case, you have a handheld, it just shows all dashed lines because there's no readings coming in, right? You don't ever get wrong readings. It's not like the interference creates wrong load readings. It wouldn't work at all, right? And so, or you might get super intermittent readings where it just doesn't work, but you don't get wrong readings, which is, that's something. It's better than wrong readings.
Important clarification. And there was another question about is the 200 hertz already anti-alias filtered?
No, that is the actual sample rate of the A to D in the acquisition module.
Good info. And they also, Justin's asking, do the transmitters buffer data at all on board averaging?
Yes, it's a good question actually. So the data, the A to D rate is set, fixed at 200 samples per second. And then one of the parameters you can set using the toolkit is how many readings does it take. So if you set it and you do it in milliseconds, so 5 equals 1 reading. So basically takes 1 reading from the A to D, and then the A to D stops. So the AD doesn't run all the time, but when it is running, it's always 200 samples per second. So how many readings? So you can say, take 3 readings, which would be 15 milliseconds. You can take 100 readings, which would be whatever, 500 milliseconds. And then you can also specify how often it transmits. So basically you tell it to take readings for, say 10 readings, and then it'll average those 10 into one data. But say you're telling it to transmit 200 times per second, that's 1 reading, send it, 1 reading, send it, 1 reading, send it. But if you say, take readings for 50 milliseconds, that's 10 readings, and then you say transmit that once per second, it's going to be transmitting the average of those 10 readings once per second. So I don't know if that completely answers the question, but that's how it works.
Good information. And there's probably more questions that you'll have. So please know that our team is here and available to directly answer those questions for you. We'll certainly follow up with any that we didn't get to in this event, as our time is near the end. So I'll just wrap this up by saying, why would you choose us? Well, as you can see, we have many different applications that we provide sensor technology for. Wireless is growing demand for a lot of lifting applications, but it's also growing in demand for in-lab and field use for all different types of sensors. We also work with many manufacturers to build OEM products that are wireless, that are utilized within their own devices and components. And that's an important feature for those that are looking to put those out in a certain environment. So please consult with us if we can help you get a specific wireless application that works for your requirements. As well, our catalog continues to grow. We have a lot of load cells, but we also have a lot of instrumentation. We're adding new technologies. If you looked at what we offered with our WTS system 2 years ago, it would be probably about 10% of what you see today. So we're continually adding based on the requirements that you're asking for. And we also are able to build and customize systems for your exact needs. Our focus on any product that we bring to market is quality and accuracy. That's key to everything that we offer. So what you'll hear here today, as well as in our detailed specifications, are answers to how we sustain that accuracy reading. Make sure that you consult with us. We do work with a lot of industries, so we have a lot of experience that we can help you in defining what exactly it is that you need. So with that, our contact is always available to help. interfaceforce.com. We have a lot of more applications we didn't talk about today, a lot of information about our wireless systems, but first and foremost, please connect with us if we can help, or you have questions. Jason, Keith, it's been a great conversation, and we really appreciate your time today. Thank you for everyone for joining. It's been a really interesting topic, and I'm sure we'll be sharing more in the future. We'll be posting our 2024 schedule here shortly about some upcoming webinars, and keep this technical conversation going.
Yeah, thanks for joining us, everybody.
Thanks.
We enjoy doing these. Hope you enjoy them as well.
Thanks, everyone.
Thanks, you guys. Take care, everyone.